TimescaleDB is a wrapper around PostgreSQL traditional database, and it is specifically designed to handle time series data. On their website here, you can see they claim to be up to 350 times faster, and so today we're going to put that to the test. We're going to start off by looking at how you can install TimescaleDB using the official Docker image. We'll then go over some basics like connecting up a table, adding some inserts, and finally we'll look at the main benefits of TimescaleDB, including how fast they are at queries, partitioning tables, and also compression of data. So let's get straight into it. So to start off with, we can immediately just come to our terminal, and what we're going to want to do is we're going to want to pull down the official Docker image. So you can do that by just coming here to Docker Hub and finding the official image, which is here. And once we've got that, what we can say is we can say docker run, and I'm just going to be following this code from, I'll just bring it over so you guys can see. So I'm always going to be following along from one of my blogs, and if we just want to copy the code directly, then you can go to johnjoewoodward.com and you can just copy and paste it if you prefer to do it that way. So let's get back into it. So we're going to say docker run name, and this is the point at which we give this table a name. So sorry, this container a name. So we're going to call it the TimescaleDB project. That's a lot. The timescale, we'll call it the timescale. Okay. We're then going to define some environment variables. So here we're just going to say Postgres password. And if you have any experience with Postgres, you'll know this is very similar. So we'll just give it a password. And then we need to map a port. So I'm going to map to port 5424. And that's going to map onto 5432. So 5432 is the official Postgres port. So I tend to avoid that because you might have installed Postgres with some other application that you've worked on, or something else might be using it. It's just best to not map specifically to that port. It tends to not work. And then we're just going to say D, so run in detach mode. And then we need the official Docker image. So we put it there. And then if you go back over to here, you'll notice that it said there is no latest tag, and you have to be specific. So this is what we're going to use instead of the latest tag. So we're going to say here, and this should create for us a new Docker container. So if I now do docker ps, and we should see it here. So it's called the timescale. Okay. If I do docker ps, what did I do before? Did I do docker ps or did I do, yeah. Okay, so that's now running. Okay, so that's great. So we can now connect that to pgadmin so that we can start viewing this data. Okay, so what I'm going to do is I'm going to come into pgadmin, and if you don't know how to install and work with this, then you can follow along on my blog, and I talk through exactly how you can install pgadmin 4. So all this is a graphical user interface so that we can view and visualize all the data that we're working with. We could do this in Python, but I find it's better to just keep these two things completely separate. We'll connect to it with Python a little bit later on, but I think it's best to have both. Okay, so now we can register a new server. So if we just register a new server, and we'll call this the timescale, and we'll come to the connection, and this will be localhost, and then the port number will just be the number that we defined earlier on, which was 5424. The username will default to Postgres, and the password we set was password. If we hit save, this should work. Okay, cool. So we now got the timescale, and if we go into this, we go to databases, we go schemas, we go public, and we go tables. There should be nothing there. Okay, so now we just have an empty database. We can actually start to insert some stuff. So if we just open up an editor now, what we can do is we can import CycloPG2, which is basically going to be the way in which we connect to this database, and it's one of the simplest packages that you can use. The reason I like it is because it's the lowest level. You can keep all your SQL commands separately. So if you look here, I've got an SQL file where I keep my SQL commands, and that means that I can reuse these SQL commands in pgadmin 4, or say there's some other place where I want to use these commands, rather than having them in a Pythonic way where they can only be used within a Python file. So what can we do now? Well, we can connect to it. So if we just tab this here, so To create a connection, you need a host. It was localhost. You need a database. The default name, as you would have seen in here, is always Postgres for the database name. You need a user. This again defaults to Postgres. The password we set was password. The port we gave was 5424. So we're going to add that there. Okay. And now if we just do con.cursor, and we just run this, let's see if this works all fine. Okay, so that works fine. So now we know that we've got a connection. Okay, so what can we do now? Well, we can create a table. So if we want to create a table, we can create a table of stock prices. And they've skipped a step that I wanted to tell you about. Okay, so we can start off by creating a table. So create table with not exist, the exact same way you do it in Postgres. You give it a name, we're going to say stock prices. Let's look at the few differences that we have immediately between Postgres and Timescale. So immediately you can see there's no key. And the reason for that is because we're going to be using specific times, and that's going to act as the primary key. So you can see here timestamp with a time zone. And then we're just going to have a ticker. So let's say, for example, Apple. And then we're going to have a price. Okay. So we actually want this to be double precision. Okay. Okay. So once we've done that, there's one more step to make this a proper timescale database, and that's to make it a hypertable. Okay. So if you see here, this command here, what we're doing is we're executing select create hypertable. And all that's going to do is it's going to take the table that you insert here, which is stock price, is the same one here, and it's going to partition it based on the variable you choose or the column you choose. So for us, we're going to partition it based on time. So that means that as time goes on, we can just create separate little chunks. So rather than having a huge table that goes from 1995 all the way to 2025, we might have each chunk being an individual year and end up having 35 individual chunks. And the reason for that will make more sense as we go on in this video. Okay, so we've got this table. If we just do con.commit, we should, if we run this, we should start seeing an empty table in pgadmin4. So if I come in here, we see tables is empty. Let me just close these down. So you can see tables empty, but if we hit refresh, we now have stock prices. And if we do view or edit data, we should see there is no data. Okay, so now let's input some data into it. Okay. So where was it? Timescale YT bid. Okay, so now that this is done, we can just comment all of this out. We don't need to do this any more times. Okay. So now we can actually insert some data. Okay. So what we're going to do is we're going to say for IM range 500,000. No, let's just do 10,000. 10,000. We're going to add some random dates and random times here. 10,000? Yeah, let's do 10,000. So, right, let's import some packages. So we're going to import random and we're going to have date time. And what this is going to allow us to do, so we're going to generate a random date between 10 years ago and now, okay? Then we're going to execute, insert into stock prices, a time, a ticker, and a price. The value's there. So time is going to be a random date, which is given here. Yeah, as you can see, we've got the time zone, we've got time delta. Okay, perfect. We're going to say Apple, and then we're going to give a random, get a random number in this range between 100 and 200. Okay, that's fine. Yep. And then we're going to commit it. Okay, so this should all run fine. So if we run this now, you'll notice that this insert is identical to how you would run it in Postgres. So now if we come to here and we run this again, we'll see that we now have all of this data. And you'll notice that we don't have a primary key. It's all based off of the timestamp. Okay, so that's how to get started with Timescale and create a basic database. The main differences, just to reiterate, are that we're going to create a hypertable and we're going to use the timestamp as the primary key. Okay, so now let's start looking at some of the advantages of it. So what I'm going to do here is I've got two databases that I set up earlier. One is with Timescale and one is with Postgres, hence the naming conventions here. And I've already created the tables. So these already exist. So you've got stock prices and you've got stock prices random dates here. And if we go over to pgadmin4, we can actually see these. So let's close this down. and you'll see I've got Timescale YT tutorial and Postgres YT tutorial. And we can open up both of these up, and we go to stock prices, view edit data, and we look at all rows. And you'll notice there are 800,100 rows. If I do the same thing for the timescale database, open stock prices, I think it did random dates, so view edit data, and we look at all rows again, you see 800,000. So roughly the same, okay? So what do we want to do from here? Well, what we want to be able to do is see how it can be faster at querying, how it can partition data up, and all of those good things. So if we come over to the one in timescale, what we can do is we can take a look at some of these queries here. So the first thing that we can run here is we can find out how many chunks or how many partitions the database has selected it up into, split it up into, sorry. So if I paste this here and I run this script, we can see that in this database, so this is the whole timescale database, stock prices random database has 2 chunks, so 2 partitions. Obviously, because this isn't actually that much data, you know, you're talking about normally dealing with millions and maybe even billions of rows of data in some instances for truly getting the benefits, the speed benefits. Okay, so now what we can do is we can go and we can actually look and see these chunks. So if we copy this, and I'll put all of this, if you leave a comment below, if you want to see this this code, then I'll leave a comment below and I'll send you the GitHub repo. So if we paste this here, we can say get number of chunks for their names in Hypertable, chunk name, range start, range end, timescale chunks, Hypertable name equals. So if we just copy this, paste this here, and we run this, and we get an error. Insert DB name here. Okay, so potentially, let's run this. So the Hypertable name, why isn't that working? Let's try and remove this. I've left in the bloody comment, that's what I've done. Okay, there we go. So don't leave in the comment. There you go, note to self. Have I not commented that out? That was a bit silly of me. Okay. Cool, so now we can see that we've got these 2 separate chunks. We can see when it starts. This one starts on 13th of the 3rd. This one starts on the 20th of the 3rd. So it's split it up by weeks, we can see here. Okay, and obviously if you have more data, it might be more, it might be less. You just don't really know how this does. This all works automatically. And there are options to manually do it, but that sort of takes away one of the benefits of using a database like Postgres. So now that we've done that, we can actually see how many rows are in each chunk. So if we take this here, and we can come here and paste this here, and we need to now say select count from, insert chunk name here with timescale internal DB prefix. Okay, so it's going to be this prefix here, underscore timescale.internal, and then we can add the chunk name here. So if I just take this chunk here and copy and paste this here, it should tell us, he says, how many rows are in that specific chunk. Okay, so we can see there's 268,750 out of the 800,000 initial rows we had have been split up into this partition. Now at this point you're probably thinking, well, what is the actual benefit of this? Well, there's 2 key benefits of this partitioning that I found. The first one is that you can create materialized views. So you can start adding, for example, if we wanted the average price of that week, let's imagine that you have, to be super simple, you have 100 rows of data and you want to get the average price for those 100 rows. What you'd have to do is you'd have to loop through each 100, go through 1, 2, 3, 4, 5, all the way to 100, then divide by 100. But now imagine you're working with TimescaleDB and it split it up into 5 different databases of 20 rows. And it automatically gave you the average price for each of those rows. So instead of going all the way from 1 to 100, all you're going to do is add from 1 to 5 and then divide by 5. Okay, so there is a benefit to this, and it can be extremely quick if you're dealing with large amounts of data. And you'll see it even with something like 800,000 rows, you will be able to tell the difference. So we'll go through that. So talking about these materialized views, let's start off with one. So if we come here and we can paste this here, we can look at this. So we can create a materialized view, which is going to be called stock prices daily. Okay, so obviously you can tell what we're trying to do here is we're trying to effectively for each day get the average price, and we want that to stay. So let's say we're dealing with tick data of stock prices. So every single microsecond or every single second, you're going to be updating this database with these prices. And then to get the average over a period of a year is going to be insane. So you're going to want to basically average those up as you're going for each day. And then when you go back historically to try and find out, oh, okay, what are the averages? It's going to be way faster. And this is just one example, right? There are lots of different complex ways that you can sort of want to query your data, but this is just the simplest way to get started. So we're going to say TimescaleDB.continuous. So this just means it updates automatically. We're going to do this based on the column name of the ticker. Okay, so for example, we're working with only Apple stock at the moment, but we might want to add more stocks in. We're going to create a time bucket of 1 day. And so we change this to time as day, and we're going to get the average price, which is price. I'm pretty sure we called it price. Yep. And then we're going to group it by ticker and day. Okay. So if I now run this script, okay, so this already exists. Okay. So I've obviously already done this, but this would work. Okay. So you guys can take my word for it, or this would have failed rather than saying it already exists. So now what we have is a rolling materialized view, creating these averages each day so that if we want to go back on this data historically, it's going to be super quick. So now let's look at the speed difference. Okay. So firstly, let's look at this query in Postgres. So if we come here and we take this query and we go to the traditional Postgres database. So the Postgres YT tutorial, stock prices, view edit data, all rows. And we're going to run this query. Okay. And it's going to tell us how long this took to run. So if we just run this here. Okay, the table name is just stock prices. So if we run this again, yeah, this is time. Yeah, that's a good point. Okay, so we don't already have the time buckets in Postgres, so that's not how we're going to be able to do this. Okay, so let's see what we can do. If we come into this chat here, how can I run the below SQL query in Postgres? We do not have time to see. Okay, so now if we wanted to actually see how fast that actually is, what we can do is we can run 2 queries here to try and actually see how slow this can actually be. So if we come here, how slow or how much faster timescale can be. So if we come here and we can see, so let's remove the limit. We run this query, 790 milliseconds, okay, to get the average price. If we copy this and we come to the timescale one, we run the exact same query, we'll see it ran in only 212 milliseconds. And there's the exact same amount of data, and the reason for that is because it already has these rolling averages which are being saved into these partition views. Okay, so it is super fast. And we can actually also now do this, which might even be even quicker. So if I come here into the timescale one and I run this, get rid of the limit. 33 milliseconds. Okay, so it is incredibly faster once you have this. Okay, so that just goes to show the benefit of these materialized views that you can be setting up. Okay, so the last thing we can do is we can look at compressions. Okay, so if we want to see, let's say for example, we have a lot of historical data and it goes back for I don't know, let's say 100 years worth of data, or even just 20 years worth of data, I might only be looking at the most recent 1 to 5 years of that data the vast majority of the time. So I wouldn't want to have the other 15 years of data slowing my database down. And so what Timescale has the ability to do is to actually compress that data. So what we can do is we can come here and see and check if it's currently compressing any data. So we go over to the Timescale database, which is here. We can run this query which says select hypertable name, compression enabled, hypertable, where the hypertable name equals, I'm pretty sure this is just going to be stock prices. So if we run this here, and we can see that the compression isn't enabled yet. So if we wanted to manually go in and do this, we can come here and we can say alter table stock prices, which is the name of our table, and we can say compress, and we want to choose the column that we want to compress it by. So for example, here we might want to compress this by time, and if we run this query, notice default order by hypertable stock price is set to true, alter table query returned successfully. So now if we go back and run this query, we should see enabled. So we can see now the compression is enabled. And so what this is going to do is it's going to compress all of the old data that we're not working with and allow us to have much faster queries and also save a lot of space. So that was a brief overview to TimescaleDB. I think my summary of it is that the benefits are you use all existing Postgres queries. It's just a layer on top of Postgres, so there's no real need to learn anything. One thing I did find is that inserts are slightly slower. So if you're more concerned with inserting data, it might take a little bit longer because if you think about it, it's doing a few things under the hood. But if you're working with a lot of time series data and you're going to be querying it often and time is of a concern, then this is a great solution for you. If you found this video interesting, make sure to subscribe because we're going to be doing KDB Plus next. Cheers, guys.